Hi everybody, this is Dr. Nigro with the Chem Calculations Screencast, this time focused on molarity and dilution. All right, remember molarity is a measurement of the concentration of a solution. All right, we talked quite a bit. All right, you can qualitatively determine concentration in some cases when you have solutions. If there's a color difference, that's the easiest because it gets darker and darker and darker in terms of color as you add more and more and more solute. But a lot of solutions out there are actually clear. So it can be very difficult to determine the amount of solute within that particular solution just by qualitative means. So instead, we use quantitative means such as molarity. All right, now remember, when we deal with solutions, it's always a good idea to identify the parts, and I tend to abbreviate the solute with a U, so you're going to see that quite a bit today. All right, I use a V to represent the solvent, and then if needed, I use an N to represent the sum or the solution. Okay, now molarity itself, we use a large capital N to represent molarity, and to calculate it, you need to know the moles of the solute, and we then divide that by the volume of the solution. All right, not the solvent, but of the solution. And this needs to be in liters. All right, so moles of solute divided by liters of solution. All right, now the calculation itself is pretty straightforward. All right, we'll do a couple examples in just a minute. The dilution question is actually something that you guys probably come into contact quite a bit. All right, when you dilute something, what you're really doing is you're decreasing the concentration by adding in additional solvent. All right, so anytime you've had, say, a cup of coffee or a glass of tea and you've added in additional water, then you've diluted your solution. All right, so the formula for this is pretty straightforward too. The molarity of your concentrated solution times its volume has to be equal to the molarity of your dilute solution times its volume. So we have the concentrated values here, and then our diluted values here. All right. A general rule of thumb is your concentrated molarity should be greater than your dilute molarity, and your concentrated volume should be less than your dilute volume. All right. And the difference here is due to added solvent. All right, so usually what happens is we take a little bit of our concentrated solution and then we add in additional water or benzene or whatever our solvent is for that particular system. All right, so let's try a couple of these. All right, so what is the molarity of a solution that was prepared by dissolving 14.2 grams of NaOH in enough water to make 350 milliliters of solution? All right, so again, I start by identifying the components of my solution. All right, it says dissolving NaOH in water. All right, so we dissolve our solute, which in this case must be NaO3, into our solvent, which is H2O. And the sum of those gives us our solution. All right, so for molarity, we need moles of solute versus liters of solution. So I have a volume for my solution, but I have grams of my solute. So my first step is going to be to take those grams and convert those over to moles using the molar mass. All right, so I use my periodic table in my calculator, whoops, and I find that 1 mole of NaNO3 has a molar mass of 133.01 grams. That seems a little high to me. Let me check that. That seems high. All right, so let's try. We'll do this one together. How about that? So we have 16 times 3 for oxygen, plus 14.01 for our 1 nitrogen, plus 23 for our sodium, and we get 85.01. I thought that sounded a little high. All right, so let me try that again. So we have a molar mass here of 85.01 grams, and that's NaNO3. All right, so if we take our 14.2 grams and divide that by our molar mass, we're going to find that we have 0.167 moles of NaNO3. So there are moles. We go to our formula. Molarity is moles of our solute divided by volume of our solution. All right. And we need that volume to be in liters. So we've got 350 milliliters. All right. We divide that by 1,000 and we have 0.350 liters of our solution and 0.167 moles of our solute. So if we divide 0.167 by 0.35, we're going to have a molarity of solution of around 0.48. Now for units, you have two choices. You can write moles per liter, that's perfectly fine. Or you're going to see many times 0.48 with a large capital M after it. And that M stands for molar, okay, which is moles per liter. Okay, let's look at number 2. All right, this one's going to run the other way. This one asks how many grams of KBr will we need to prepare 700 milliliters of a 0.23 molar KBr solution. All right, so again, I'm going to identify the pieces of my solution. All right, the chemical entity given with the molarity is always going to be your solute. So in this case, KBr is our solute. All right, I'm going to assume that this is water, all right, an aqueous solution. We should have included that. We should say 0.23 molars KBr AQ, so you know that. But generally speaking, we will be dealing with water as our solvent, all right? And then the two together, that's the sum. All right, so this time I'm going to start with my volume and my molarity and work my way to moles of solute. All right, so molarity is moles of solute divided by volume of solution. All right, in this case, I have a 0.230 molar solution. I don't know the moles, but I do know 700 milliliters. If I divide that by 1,000, I have 0.7 liters. All right, so I'm going to rearrange and solve, and I find that I have 0.161 moles of KBr dissolved within that solution. All right, but the problem asks for the answer in grams, so I'm going to need to do a conversion. All right, and I know that 1 mole of KBr has a molar mass of 119 grams. All right, so I multiply 119 times 0.161, and I find that I'm going to need to dissolve 19.2 grams of potassium bromide in 700 milliliters of water to prepare a 0.23 molar solution of KBr. All right, so this next one is going to be a dilution problem. All right, so if water is added to 175 milliliters of a 0.45 molar KOH solution, until the volume is 250 milliliters, what will the molarity be of the diluted solution? All right, so there are many ways to keep track of your data. I tend to form a little table where I have a molarity and volume row, and then I make one column, which is my concentrated values, and one column, which is going to be my dilute values. All right, so I go and look. All right, I have 175 milliliters versus 250. And as I said before, the volume of the dilute will always be greater than the volume of the concentrated. So that helps me identify which is which. And the 175 is of a 0.45 molar solution, so that must be the concentrated value. And my unknown is going to be M sub D. All right, so molarity of the concentrated, volume of the concentrated equals molarity of the dilute, volume of the dilute. We're going to plug our values in. So 0.45 molar times 175 milliliters. All right, now you may ask, does it have to be in milliliters? Can I change it? You can. The key here is your volume units just need to match each other. So you can't have one as milliliters and one as liters, but you can have both as milliliters or both as liters. All right. Our unknown is the dilution molarity, and then we'll have a volume of 250 milliliters for our dilute volume. All right. We do some calculating and then a little bit of algebra, and we find that our dilute molarity is going to be 0.315 molar. All right, now to check, remember I said the molarity of the concentration should be greater than the molarity of the dilute, and if I check, that is the case. All right, so that tells me at the very least I've set my formula up correctly. All right, now let's try this problem. How much water would need to be added to 750 milliliters of a 0.28 molar solution if I want to dilute it to 1.3 molar? All right, so again, I'm going to set up my little chart so that I can keep track of my variables and my numbers. I'll have concentrated and dilute. All right, so I'm clearly going from 2.8 molar down to 1.3. So 2.8 molar will be my concentrated, 1.3 molar will be my dilute. And it says I have 750 milliliters of that concentrated solution. So my unknown is going to be V sub D. All right, so again, MCVC equals MD VD, we plug in 2.8 molar times 750 milliliters equals 1.3 molar times V sub D. All right, so we do some math and we find that the volume of our dilute solution is going to need to be 1,615 milliliters. All right, but that's not what the question asked. The question asked how much water would need to be added. All right, so if my final volume is 1,615 milliliters and my initial volume was 750 milliliters, the difference is going to be the amount of water that I'm going to add in, which turns out to be 865 milliliters of water added. All right, so make sure when you're working these concentration problems, they seem pretty simple, but make sure you're answering the question that is being asked. Okay, so those are just a couple of examples that work through molarity and dilution problems. Remember, molarity is just a quantitative measurement of the concentration of a particular solution. It's moles of solute divided by volume of solution. All right, so I could write this up here as moles of solute divided by volume of solution. That volume needs to be in liters for it to be molar, okay? Dilution occurs when you add additional solvent into a particular solution, and we look at the molarity of the concentrated times its volume equal to the molarity of the dilute times its concentration. Its volume. So keep in mind that the molarity of the concentrated should always be greater than the molarity of the dilute, and the volume of the concentration should always be less than the volume of the dilute. Okay? Okay. Hope